if you took algebra and geometry, algebra 1 and geometry, you should have somewhat of a background in solving equations. Somewhat of seeing it before. You may not know it as well as some others because you had different teachers. Okay? Here's what we're going to do. Today I'm going to go through some examples. Some you may have seen before, some you may have not. Okay, it's in your notes. Okay, you can learn it or review it. Now, when you do your homework and I get it back, I want to see what you know, what you remember about solving equations. You may not need to be able to do all of them. Some of them, they're very different. Okay, there's not just one type of solving equations. I have different ones on there to see which ones we might have to hit. Okay, or go over before we move on. Okay, so I want you to do the best you can. I'm going to go over some of them right now. Solving equations, that's the title. So if you want to put that on top, solving
0.3.
Yep, 0.3. Here's what an equation is. It's a mathematical sentence with a variable in it. Okay. For example, if I have a plus 6 equals negative 12. How do I solve equations? Well, first thing I have to remember, I'm going to do my sidebar like I always do to kind of remind myself of things. I have to get the variable by itself or get the variable alone. And the way I do that is by using the opposite operation. Opposite of addition is what? Subtraction. Opposite of subtraction? Addition. Crying out loud. So those are interchangeable. Opposite of multiplication? Division. Those are interchangeable as well. Division is multiplication. Now, so in order to get a by itself here, I subtract 6 to both sides. Use the opposite operation. Okay? Something else you have to remember about solving equations. Whatever you do to one side, you must do to the other. You can never do it to just one side. 6 minus 6, those just cancel out. I'm okay if you just put a line through. Some teachers make you put the 0. I'm okay with the line. As long as you show the line. Don't leave it blank. Either show a line or put 0. A equals negative 12 minus 6, negative 18. That's a one-step equation. We did one step and we had the variable by itself. We know that A equals negative 18. If I would plug negative 18 in here for A, I'd get negative 18 plus 6, which does give me negative 12. It's correct. Now, they get a little more complicated than that. How do I solve something that looks like this? Divide by 2/3. But when I divide by fraction, a divided fraction, what is that also known as? I think you said it. What did you say? Multiplied by the... Yeah. Isn't dividing fraction the same thing as multiplied by the reciprocal? So I'm going to skip a step here. Okay? I'm going to say if you see something that looks like this, you say, okay, well I would normally need to divide by 2/3. But instead of dividing by 2/3, I'm going to multiply by the reciprocal because dividing a fraction is the same as multiplying by the reciprocal. So here's what I'm going to do. I'm going to put 3 halves on both sides. Multiply by 3 halves on both sides. The reciprocal of 2/3 is 3 halves. That's kind of helps you skip a step. Now in this case, if I cross reduce because I'm multiplying fractions, these all just cancel out and I'm left with 1g, which is just g. On this side, I have negative 12 over 1 times 3 over 2. Multiplying fractions. First step, cross reduce. Negative 12 and 2 are both divisible by 2. Negatives. There we go. And 3 and 1, I can't reduce 1 to anything else, so that just stays. Now, multiply straight across. Negative 6 times 3, negative 18. 1 times 1. So G equals negative 18 over 1, or G equals negative 18. Now, in order to solve for x here, I have 2 x's. That's a problem. I can't solve the equations for 2 different x's. I need to put the get the x's together. But I can't because I have parentheses. How do I get rid of those parentheses without actually having to take x plus 3? Yeah. Distributive property, so I multiply the 2 by each thing inside the parentheses. If you use a distributive property, make sure you show me your arrows. Okay, so I have 2 times x plus 2 times 3, which is 6. And now I'm going to use it again. 3 times x minus 3 times 3. 9. Now what? I still have x's on both sides. I can put
x plus 6 minus 9 or something like that.
You're close. I have to get this x over here or this x over here.
Subtract 2x from both sides.
There we go. Subtract 2x from both sides. So I'm left with 6 equals 1x or just x minus 9.
And add 9.
Then I add 9 to both sides. Very good. So x equals 15. Some teachers make you rewrite it, x equals 15. I don't. I'm okay if you just leave it 15 equals x. Now, let's do another one. Same problem as before. I have x's on both sides, and I have parentheses. So I'm going to use that same distributive property and get rid of those parentheses. So I'm going to have 3x plus 6 equals negative 5. Now, this is why I wrote this problem down, because you have to be very, 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 very careful here. Why? What am I thinking?
You have to multiply with the negative number.
Right. Subtraction is the same thing as plus and negative. So this is a negative 2. When you distribute this, you have to take the negative with you. So I have plus negative 2x minus negative 6. I took negative 2 times x. I got negative 2x. Negative 2 times 3. I got negative 6. Subtraction is still there. Now you can fix it back if you want. Some students prefer to do this. So if there's only one operation, I know that plus and minus, or plus and negative, is minus, and minus and negative is positive, or plus. So if you switch it back, then you only have one operation to deal with when you solve the equation. Some people don't like to do that. That's okay. I don't care either way. I like to switch them back. Now, I'm going to combine all the like terms on this side that I can. I have negative 5 plus 6 gives me 1. So I have 1 minus 2x, 3x plus 6. Now I'm going to get my x's together on one side. In order to do that, I'm going to add 2x to both sides. I have subtraction here. I I could subtract 3x, but then I'd end up with a negative 5x. I don't like negatives if I don't have to. Okay? So I'm going to add 2x to both sides. Negative 2x plus 2x just cancels. 3x plus 2x is 5x. Now what?
Subtract 6.
Yep, subtract 6. So I got 5x equals negative 5. Divided by 5. X equals negative 1. One more. You like these? I know, I love social equations. Me too.
Better than fractions.
Well, speaking of fractions,
For real?
let's go too soon. Here's what it looks like.
Are we writing this down?
Yes.
Roger now.
The last one.
For some afternoon announcement.
No, I don't want any.
For the conclusion of the day. Attention to all of our
Try that on
drivers.
your seat while you're listening. Yes, we're going to cross multiply. Now, before you cross multiply, there's a negative sign there. Let me ask you a question. Where do I put it? Doesn't matter, does it? I can have negative x over 3. Negative x over 3, or x over negative 3. It does not matter. You'll get the same answer. But you cannot put negative x over negative 3. That is wrong. So when I cross multiply, I'm just going to say I have x over negative 3 equals 4 over 9. Cross multiply, x times 9 is 9x equals 4 times negative 3,
Negative 12.
negative 12.
Divide by 9.
9 divided both sides by 9. So unless x equals, well, I could leave it negative 12 over 9, but I want to reduce that first. Yes?
4/3 or
4, divide both by 3. Negative 4 thirds.
That's what he
Is that what you said?
yeah.
I'm sorry. I didn't hear you. My fault. Yes, there it is. Very good. Okay. If you did your notes, you just got about 7 answers to your homework. So that means you only have 13 equations to solve. If you didn't do notes, that means you have them all to do.